balance there might be. You've got to decide on the number of categories in your measurement scale. We spoke about that yesterday. I think 5 is fine. I normally don't force them to make a decision between positive and negative outcomes, but I think that is a case that anybody can make up for themselves. Do you want to use an odd number or an even scale? Over to you. Look at measurement scales, and that's the point here in terms of the Likert scale. You look at order, distance, and origin action. So what you're actually assuming in a Likert scale is that the order is from not at all to absolutely so, that the distances are equal between them, so 1 and 2 and 3 and 4 and 5 have equal distances between them, and that 0 could be or could be not a point where nothing happens. It's your choice to decide that. So you could use a Likert scale from -2, -1, 0, 1 and 2, or you could use one as 1, 2, 3, 4, 5, in which case the point 0 doesn't indicate absence. Measurement scales. I'm going to do 2 slides on this. The first slide talks about single item scales, and then the next slide will talk about multiple item scales. All right. If you read through this in the textbooks, you'll see that they just give you a list of all of the possibilities, but I like to put them under single item and multiple item scales so that I sort of have a logic to work with. So under single item scales, I have a couple of them which I think you all know, you just never knew about the names. There's an itemized category scale, then paired comparison scale, constant sum scale, pictorial scale, and continuous scale. So the itemized category scale allows you to go from highly satisfied to highly unsatisfied, or the other way around if you want to. That depends whether you want to use 1 as priority number 1 or 5 as priority number 1. It's your choice. But what itemized category scale gives you is categories that you itemize. So from highly satisfied to highly dissatisfied, there are categories. The second one is a rank order scale. So here's an example where it's actually a 3 in 1 about the same. So I give you 3 makes of cars, and I ask you rank them in order of importance on price, on mileage, and on general value for money. So you've got a 1, 2, and a 3. You've got to allocate 1, 2, and 3 to each one of these cars based on price, then based on mileage, and based on general value for money. So with one table, I get a lot of information, right? And all you got to do is say, Jaguar is first on price, or not the best on price, so maybe I give it a 3. It's definitely good on mileage, and it's general value for money. So I could give it 1s, and I'll give a BMW a 3, and I'll give a Mercedes a 2, whatever. So I got 1, 2, and 3, and I allocate that as a rank order, depending on how I feel about every one of those. I think it's a very nice tool to use to get a lot of information right at the outset about a lot of things. The second one is paired comparison scale. So on the paired comparison scale, you would give them 2 options, and they've got to compare the 2 options. Which ones of the 2? So you've got to be very good at these 2 options, that what you compare against each other would be valuable in terms of your research. So it actually requires of you a lot of planning to have options that you can compare. So you look at something and you'll say, is this good value for money or bad value for money? Is this strong on this and bad on this? And you've got to decide what you will put under these 2 items for comparison. The next one is a constant sum scale. So you have a total, and you divide that total amongst the items that you're measuring, and they can choose how they want to do that. And the pictorial scale uses little smileys from not at all, or not happy at all, to absolutely, and they choose a smiley. And a continuous scale is a box, and they draw the cursor up to where they want the cursor to be, from 1 to 100 if you like. So you get a lot of information on a continuous scale that you wouldn't get if this was 0 to 5, if you want that. So those are the single item scales, and then here are the multiple item scales. There are two of them, semantic differential scale, I'll explain it now, and then the second one is a Stapel scale. And they work as follows. A semantic differential scale will give you opposites, and you've got to choose between two opposites. So contemporary vis-a-vis old-fashioned, for instance. So semantic differential differentiates something in terms of two options. And then a Stapel scale puts the item that you are dealing with in the middle and then allows you to look at that item from very negative to very positive. You could probably there use -3 to +3, which would be better than -5 to +5. So we have two sets, single item scales and then multiple item scales, and these are the basic options that you could use in measurement scales.